So let's look at the problems that my algebra students loved so much. And they are word problems. So I want you to go ahead and read the first one. Find out what they're looking for. Select the variable x, y, z. Represent the quantity that they're looking for. In this case, it says how long will it take Ariane to catch up to Ivana. So how long, we're looking for time. So you can pick your variable, x, y, z, whatever, set it equal to the time to catch up. And basically what you want, again, is two quantities. At least one of them has to involve the unknown or variable that you're looking for. You're going to want these two quantities to be equal, because then you could set them equal to each other. And then you have the equation that you want to solve. Now there's some problems that you can solve without generating an equation. Trial and error. But generally the instructor is going to want you to set up an equation and then solve it. So go ahead and stop the video and see if you can solve the first one. And then I'll come back. Okay, so let's look at it now. We have Ivana. Ivana is a long distance runner. Runs at an average velocity of 8 miles per hour. Ivana leaves Ariane's house running at 8 miles per hour 2 hours after. So that's important, 2 hours after Ivana leaves. Ariane leaves in her car and follows the same route as Ivana. And again, we're assuming that this is kind of instant, constant velocity. If the average velocity of the car is 43 miles per hour, how long will it take Ariane to catch up to Ivana? And what distance have they traveled? What it's asking you then is, at the point when Ariane catches up, what distance have they traveled from the start, or from the house they leave from? I'm going to let t for time. You can use x, y, whatever. Let t equal time in hours for Ariane to catch up to Ivana. So remember, Ivana takes off first. So at the time that Ariane catches up to Ivana, she's going t hours. But remember, Ivana had a 2 hour head start. So she's going to have the same time as Ariane plus 2. So t plus 2 equals Ivana's travel time at point when Ariane catches up. Okay, so that's the way we start off. And now we're going to look for two quantities that involve the variable. And we want these two quantities to be equal. So let's start with this. So this is the house they leave. This will be start. And this will be C. I'll put C here for catch up. So this is a distance traveled at the point when Ariane catches or is even with Ivana. So what is this distance here? How do I express this distance for Ariane? Well, Ariane leaves in a car and it's going 53 miles per hour. So I'll put 53. That's the velocity. I'll leave the units out for right now. And that's going to be multiplied by the time in hours. So this is miles per hour. And this is going to be multiplied by the time, which is going to be t. Now at the point when Ariane catches up, the distance for both of them is the same. So for Ivana, she's going at 8 miles per hour. So distance is equal rate times the time. So this is multiplied by her time. Her time is 2 hours more than Ariane because she had a 2 hour head start. Okay, so there I have it. Above it, Ariane's time, 43 miles per hour times t. I'm leaving the units out for now, but notice the hours cancel out, so that's going to come out to miles. And then for Ivana, it's 8 times her time. But what do we know? they both start from the same spot and they wind up at the same point when everybody catches up. So that tells me then these two distances represented by 43t and 8 times t plus 2 are the same. So I can just say that 43t is Ariane's time, and 8 times t plus 2 is Ivana's time, and these have to be equal. So basically then I just solve this equation for t. So this is going to be 43. Multiply here by 8. That'll be 8t. 8 times 2 is 16. This is 43t here. So I subtract 8t from both sides here to isolate the variable. So subtract 8t here. Or I can say add a negative 8t, either way. Negative 8t here. So that would give me then on this side 35t. And over here that the 8t and the minus 8t cancel. This gives me 16. So I can just say that t is equal to, dividing here by 35, both sides by 35, I get 16 over 35. Okay, so it's 16 over 35, and this is in hours. Now if I want a decimal approximation here, I can just divide this out. 16 divided by 35. I round it out to 2 places. This will be 0.46 hours. So 0.46 hours is what it takes. Okay. A little less than 1 hour, or about 27 minutes. Okay, so this is one answer to the problem. How long does it take everybody to catch up? So 0.46 hours, or approximately 27 minutes. And what distance have they traveled? Well, you can just multiply 0.46, okay, to get the distance. Multiply by the rate for either one of those, and you're going to get just under 20 miles, 19.7 and 19.8, depending on how you round off. So let's just say right under 20 miles is the distance traveled when Ariane catches up. And that is the solution to that problem. Clear this? Okay, so that's one involving distance. There's many problems involving mixtures. This one dealing with antifreeze. You could have some involving gasoline or oil, some refineries, or maybe you're cooking. It could involve a mixture of ingredients for a cake, so forth. So let's see what this one says. How much water, again, stop the video if you want to try it on your own. How much water should be added to 1 gallon of pure antifreeze? Remember, we've got 1 gallon of pure antifreeze to obtain a solution that is 60% antifreeze. So obviously the 1 gallon is 100% antifreeze if you just have 1 gallon. But we want to add water to that. Okay, water it down so that the percent of antifreeze is 60%. So here, then, think about that for a while, what they're asking. So I'm going to let x equal to the amount of water, because that's what we're looking for. How much water should be added. And again, always make sure you have it with the same units. Okay, you got gallons, so you don't want to use quarts. Okay, if you're dealing with feet and inches. Okay, consistency, you have to convert one to feet, inches to feet rather, or feet to inches. Again, that's going to depend on what they ask, what unit they ask for. So in this case, we'll let x equal to the amount of water, and then we'll leave it in gallons that should be added to obtain 60% antifreeze or antifreeze solution. So I'm going to add the water to the pure antifreeze that I have. So 1 plus x is equal to the amount of solution. All right, I started with x equal to the amount of water that should be added to obtain 60% antifreeze solution. So to the 1 gallon, I'm going to add x gallons of water. So 1 plus x is equal to the amount of solution in gallons. Now, since I want it to be 60% antifreeze or antifreeze, 0.6 times 1 plus x should equal to the amount of pure antifreeze. 1 plus x times 0.6, 60% antifreeze, equals to the amount of pure antifreeze in gallons. But I already know that 1 gallon is equal to the amount of pure antifreeze. These two quantities right here then, these two should be the same, because they both represent the amount of pure antifreeze. So we set those equal to each other. So now it's just a matter of solving this equation for x. So multiply through 0.6 times 1 is 0.6. 0.6 times x would give me 0.6x equal to 1. Okay, subtract 0.6 from both sides. So subtract 0.6 from this side, that cancels, that'll give me just 0.6x. And subtract 0.6 from the other side, that'll give me 0.4. Divide both sides by 0.6 to isolate the x. This cancels out, and I'm going to get x would equal to 0.4 over 0.6. But I can simplify that, multiplying by 10 and 10 here to get rid of the decimal. I can write this as 4 over 6. That's the same thing. It's 0.4 times over 0.6. And then you can reduce this to 2/3. So the amount of water that should be added to get this mixture of 60% antifreeze is 2/3 gallons. And that, of course, is water. So 2/3 gallons of water should be added to the antifreeze, to the pure antifreeze, to get the 60% mixture. Clear this. This one again deals with velocity and distance. So a motorboat heads upstream on a river that has a current of 3 miles per hour. Now, the trip upstream takes 5 hours. Now, upstream, it's going against the current. Okay. And the return trip, that's downstream, the current is pushing the boat. So it takes less time. 2.5 hours. What is the speed of the motorboat? And again, assume that the motorboat maintains a constant speed relative to the water. Okay, so it doesn't stop and then take off. It's constant speed. So we're looking for the speed of the motorboat. we'll let x equal speed of the boat. And again, the units is going to be in miles per hour. The speed of the current is 3 miles per hour. So x minus 3 equals speed of the boat going upstream. That's against the current. And then going with the current or downstream, the speed of the boat downstream is x plus 3 miles per hour. Okay, so here's the deal. We have then, do it up here, x minus 3. That's the speed upstream, going against the current, so we subtract the speed of the current from the speed of the boat, which is what we're looking for. And this takes 5 hours. So this is the speed or rate. Rate times the time is distance. Now coming downstream, the speed, you're going with the current now. So the current is pushing the boat. So in this case, we add the speed to the speed of the boat. And because the boat is being pushed by the current, it takes less time. So this is time is 2.5. But remember, the boat is going upstream and then downstream the same distance, up and down. So this is the distance upstream on the left, and on the right over here is the distance downstream, and those have to be the same. So there you have it. Okay? And that's the technique to solving an equation again, as I pointed out earlier. Select a variable to represent the unknown that you're looking for. And generate two quantities. At least one of them has to involve the variable. In this case, they both do. And you want those two quantities to be the same, because then you can generate an equation. That's one technique that's used. And then you just multiply through here. So solve the equation for x. It's going to be 5x here, multiplying through. 5 times minus 3 is a minus 15. Get that? The right side multiply by 2.5. 2.5 times x is 2.5x. And then 2.5 times 3, 7.5. And then isolate the variable. So here we're going to subtract or add negative 2.5x here. The same thing on this side. Negative 2.5x. That gives me then 5x, and a minus 2.5x is a positive 2.5 x. Then we're going to add 15 to both sides. I'm going to add 15 on this side and 15 on this side. This is going to cancel this one here. And then the 15 and the 7.5 is going to give me 22. .5. Divide both sides by 2.5. So this side divided by 2.5 to isolate the x. This side divided by 2.5. And this gives me 9. 22.5 divided by 2.5 is 9. And then, of course, this is in miles per hour. And that's the speed of the boat. So we solved one mixture problem, standard procedure, and then two other problems, both utilizing the distance formula. Thanks for watching. We'll see you next time.